Hello, 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 and welcome back to Shiksha DaCosta. Today we are going to be reviewing our unit where we connected the graphs and equations of quadratic relations. So in this unit, we learned how to connect the graphs and equations of quadratic relations. And you're successful at this when you can make connections between the numeric, the graphical, and the algebraic representations of quadratics. And when you can use those connections to solve problems. So to start, we started this unit by realizing that any relation that has a constant second differences is a quadratic relation. And that comes from the Latin word quadratum, which means square. They're called quadratic because the algebraic expression of a quadratic has an x squared term in it. The highest degree is a degree of 2. The degree of the polynomial is 2. The shape of a graph of a quadratic is called a parabola. Okay, it kind of looks like a U shape, and although that could be upside down as well. The point at the tip of the U, the tip of the parabola, that point is called the vertex. If the parabola is shaped like a U, then the y value of that vertex, if the vertex is right here at the bottom at the tip, that is the lowest possible value, which we call the minimum. If the parabola is shaped upside down, where it looks like this, then the tip or the vertex, which would be right here, would be the highest point. The y value of the vertex will give you the highest possible value, and that is the maximum. In the second half of this unit, we started to learn about quadratics in the different forms. So a quadratic in factored form looks like this: a times x minus r times x minus s. These are 3 factors. You can easily identify the zeros, which are also called x-intercepts or roots, the zeros of a quadratic in factored form. They're any value of x that makes any of these 2 factors equal 0. So in this case, the zeros will be r because r minus r would be 0, and s because s minus s would be 0. You can also create a quadratic relation in factored form if you know the zeros and you know one other point. If you know the zeros, you know r and s, you just need to find out what a is. So you plug in x and y from another point, right? You substitute in the known zeros into r and s. You substitute the x and y into x, and y. And then you solve for a. You have to isolate a. For example, if we wanted to find the equation of this quadratic, we would just notice that, this is the factored form of quadratic. I know that I can see 2 zeros here. I can see one here at 10 and one here at 30. I can also take any other point. I can take any known points. I could take this one up here, 0 and 30. I could take this one down here, 20 and negative 10, any one that I want. And then all I have to do is plug them into my equation and solve for the unknown variable, which is a. So this is with all of the numbers plugged in. So I've chosen to use this point right here. So negative 10 equals a times x minus r times x minus s. Okay, the x value is 20, the r value, and these are all color-coded so you can see where I'm getting the information from. 20 minus 10 is 10, 20 minus 30 is negative 10, 10 times negative 10 is negative 100. And now to find the value of a, all I have to do is divide. I do the opposite operation, divide by negative 100. And that will give me that that'll tell me that the value of a, if I do the same thing to the other side, which I have to do, negative 10 divided by negative 100 is 0.1. And now a is isolated. So the equation of this quadratic will be y equals a times x minus r, and I know that r is 10, times x minus s, and I know that s is 30. In this example, let's find the zeros of this quadratic. So if even one of these factors, this one or this one, if it ever equals 0, then when I multiply them all together, the product, the answer of all 3 will also be 0. So here I have an equation, the same equation. What would make this equal 0? Well, I can't change this factor, right? This one right here, not able to be changed. What about this one over here? This one's easy to figure out. What number minus 5 gives me 0? It's pretty easy to see that. It's 5. 5 minus 5 would give me 0. So in this case, x could be 5. That would make this factor 0, and 0 times anything is 0. What about this one? This one's a little bit harder. 2x plus 1. How do I get that to be 0? Well, I can just make it equal 0 and then isolate. So I'll see here. Okay, let's subtract 1 from both sides. That would give me that. And now that will give me 2x equals negative 1. And now let's divide both sides by 2. And that gives me x is negative 1 over 2. So you can easily identify the zeros of a quadratic in factored form. They're any value of x that makes either of these two factors equal 0. Find the vertex of this quadratic. Well, how do we find the vertex if we're given the zeros? Well, the vertex, the x-coordinate of the vertex, is the same as something called the axis of symmetry. The axis of symmetry is a vertical line, x equals h. H is the average of the x-coordinates for any 2 points that have the same y-coordinate. So the easiest one to use are the zeros. So just looking at this equation, the zeros are clearly 8 and negative 2. And they have the same y-coordinate of 0. So I can take their x-coordinates and I can average them to find h. Okay, so they have the same y value, so I'll average their x-coordinates. 8 plus negative 2 is 6, and 6 divided by 2 is 3. So the axis of symmetry is x equals 3. This number is also the x value of the vertex. So what I can do is I can take that number 3 and I can plug it into my equation, and that tells me the y value of the vertex. So the vertex in this case is 3 and negative 100. Because this a value is a positive number, the quadratic, what do we look like when we are feeling positive? We smile. So the quadratic is shaped like a U. That means that this is the minimum. This is the bottom point. So how do we find the vertex of a quadratic from factored form? You find the axis of symmetry. You take that value and you find that value by averaging the zeros. So step 1 is find the zeros. Step 2 is average them to find the axis of symmetry. Step 3 is plug that number back into the equation. And there you go. You have the x and y value of the vertex. After that, we looked into how to go from factored form to standard form. So how to multiply two binomials. When you're multiplying two algebraic expressions, you multiply each term that's in the first by each term that's in the second. So in A1.5, we looked at what are binomials. These are expressions that have two terms. And expanding them uses the same rules as as I just mentioned. And it has an easy hint to remember if it's just a binomial. We just use FOIL. What is FOIL? Well, that means that when you have a binomial, so this is two terms, being multiplied by another binomial, which is two terms, you multiply the first two terms together. So A is first, and so is C. A is the first term in this one, and C is the first term in this one. So I'll multiply the first two, A times C. Then I multiply the outer two, A times D. Then the inner two, B times C. And then the last two. So B is the last term in this binomial, and D is the last term in this one. So that's B times D. And then you just add all of these together, and whatever your answer is after you've combined any like terms, that is the expansion of a binomial. So let's see an example of this. Let's convert a binomial into its expanded form. Convert this to standard form. And remember, standard form means all of the brackets are expanded and like terms are combined. So here we have our two binomials, and let's just use FOIL. The first two terms is 2x times 3x. The outer two terms is 2x times 2. The inner two terms is negative 1 times 3x. And the last two terms are negative 1 times 2. When we add these together, let's see what we get. 2 times x times 3 times x will be 2 times 3 is 6, and x times x is x squared. 2 times x times 2, well, 2 times 2 is 4, times x is just x. Negative 1 times 3x is negative 3x, and negative 1 times 2 is negative 2. Notice that these two terms are like terms. 4 minus 3 is 1. And so this is standard form. This will give you the same parabola as this right here. Now, how do we go from vertex to standard form? We learned how to go from factor to standard, but what about vertex? Well, there are three forms of a quadratic expression, right? There's factored form, which is the easiest to find the x-intercepts or the zeros. Vertex form, which is the easiest to find the vertex, that's just h and k. And there's standard form. Standard form is the easiest to turn all of the other forms into just by expanding and simplifying. The end standard form is the easiest one to help us find the y-intercept, which will just always be c. How do we turn vertex into standard form? Well, we know in our previous, in the other lesson here, in that expansion of binomials lesson, we learned how to go from factored into into standard. But in this lesson, we learned how to go from vertex into standard, and it's very similar. We just expand and simplify. Let's see, let's turn this into this by expanding and simplify with FOIL, okay? So this is our expression right here. I'm going to expand these brackets first, okay? So I'm going to use the exponent of 2 to know that x plus 3 times x plus 3 is what I've got here. And I'll just use FOIL here. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. And I'll multiply all of these. I have to, of course, keep everything else the same. So when I combine all of the terms that are inside the brackets, 3x plus 3x will combine into 6x. And now what do I have to do? I've simplified this, so now I have to go to my next order in the order of operations after exponents is multiplying or dividing. So I'll multiply 2. I do have multiplication here. So 2 times all of these three terms. 2 times x squared is 2x squared. 2 times 6x is 12x. And 2 times 9 is 18. And of course, I can't forget about this minus 1 at the end. Finally, my last step is to combine these two. 18 minus 1 is 17. And what do you know? When I took this and I expanded and simplified it, I ended up with this expression right here. Factoring quadratics. So if a quadratic that looks like this can be factored, it can be factored into two binomials where r and s, x plus r and x plus s, where r plus s gives us this middle coefficient, b, and r times s gives us the last coefficient, c, especially if r and s are integers. If you factor the greatest common factor first, that'll help you get it to look, a quadratic to look like this, and then you can apply this rule. So to do that, you find the factors of each term, you look for the greatest factor, and you divide each term by the greatest factor that they have in common. Rewrite the new expression in brackets, and then put the greatest common factor in front of the brackets to show that these two are being multiplied. If you were to multiply them, you would undo the factorization. Let's see an example of that. Factor this. Well, I noticed that 3, 21, and 36, these are all multiples of 3. So the greatest common factor is 3, and I can divide all three of these by 3, and I'll get a whole number. So 3x squared divided by 3, 21x divided by 3, 36 divided by 3 gives me this. And remember, I have to put my greatest common factor in front. Now, how do I continue to factor this? Well, I'm looking for two numbers that when I multiply them, I'll get 12. So 1 times 12, that could work. That gives me 12. But when I add them together, I need it to give me 7. I need it to give me this middle number. So 1 plus 12, unfortunately, gives me 13, not 7. So I cannot use this. I cannot use these two. What about 2 times 6? 2 times 6 is 12. But 2 plus 6 is still not 7. It's 8. What about 3 times 4? 3 times 4 is 12. 3 plus 4 is 7. So I can take this expression here, and I know that it will factor into x plus 3 and x plus 4. So let me just highlight this for us. This is the factorization of this expression right here. And of course, I keep the greatest common factor in front. So I started with this, and I factored to get this expression. And if I were to expand, I would go right back to where I started. And that's one way that you can check your work. So let's do that. Let's check if I got this right. I'm going to use FOIL to multiply my binomials, x times x, x times 4, 3 times x, and 3 times 4. When I add them together, I get x squared plus 4x plus 3x plus 12. And these two will combine into 7x. And now finally, I have to multiply all of these by 3. And that gives me 3x squared plus 21x plus 36. What do you know? This is the same thing as this. It's the same thing as what I started with. So we can see that if you were to start with this and you factor it, it will look like this. And if you expand it, it will look like this. But both of these, it's important to know, both of these are the same. They both give you the same parabola. Finally, we learned about applications of quadratics. Every situation that's related quadratically can be written in one of the three forms, or in all of the three forms, excuse me. It can be written in factored form, in vertex, and in standard. Understanding when a question is telling you the value of a variable, that will help you progress through word problems. And usually, if you can create a quadratic, or if you're given a quadratic equation in one of these three forms, and then you're given the y value, how do you solve for x? Well, what you have to do is turn it into factored form. Move all to solve that quadratic. If you're given the y value, you move all the terms to one side. So you make one side equal 0. You take the side that has all the terms and you factor it. You turn it into factored form. And then whatever the zeros of that equation are, because the other side equals 0, the zeros of that equation are going to be your solutions. Let's do an example here. Liasha wants to grow plants in her rectangular garden. The planting area is 2 meters long and 6 meters wide. And okay, so I'm just going to start with a diagram right away. So my diagram is going to be, here's the planting area. Remember, it's 6 meters wide and it's 2 meters long. And she wants to build a stone border of uniform width. Uniform means it's the same. So she wants a border that is the same width all around. So sort of like this, right? Where whatever this distance is, and I'm not sure how wide she wants it to be, this distance will be the same as this distance, will be the same as both of these distances as well. So it's the same width all around. She wants the total area of the planting area and the border. It must not exceed 32 square meters. So if she wants that to be true, what is the greatest possible width of this border? Well, this is a rectangle, right? It's a rectangular garden and it's a rectangular border as well. So the total area will be length times width. Okay, now what is the length and width of the total area here? The length is 2. What's this distance? Well, that is x. That's the same as this, right? So this is 2 plus x plus x. And the total width is 6. And what's this distance and this distance here? Well, that's also x. 6 plus x plus x. So let's replace the variables with the values that we know them to be. The area is 32. The length is 2 plus x, and the width is 6 plus x plus x. Now I'm going to start to simplify this a little bit, okay? I'm going to make it a little bit simpler for me to do. So here I have, what is 2 plus x plus x? Well, I have 2 x's, so that's x plus x is 2x, plus the 2. Notice I always like to put the variable in front. And this is 6 plus x plus x. So again, I have 2 x's plus 6. This is still the length, 2x plus 2, x, x, and 2. And this is another way to write the width. right? X plus 6, 2x plus 6. Okay, what can I do with this? Now I've come up with an equation, and this is clearly a quadratic equation, and I'm going to use the steps that I explained earlier to solve this. So first, I'm going to simplify everything here by expanding. Okay, and we know how to expand binomials, don't we? 2x times 2x is 4x squared. 2x times 6 is 12x. 2x times 2x is 4x. Sorry, 2 times 2x is 4x. And 2 times 6 is 12. And we just have to add these together, and all of them should equal 32. Now let's combine our like terms, right? We have to simplify this. 12x plus 4x is 16x, and there's no other x squareds or numbers on the right side of the equal sign, so this is what my equation simplifies to. Now what I'm going to do is move this 32. Remember, I want one side to be 0, so I'm going to get rid of 32 on this side. I'm going to subtract 32 to solve this equation. And I do that by making one side 0. So that will cancel it out here, and I'll be left with nothing on this side. But I can't just subtract one side. Whatever I do to one side, I have to do to the other. So I'll subtract 32 on this side as well. And what I end up with is 0, like I planned, equals 4x squared plus 16x. 12 minus 32 is negative 20. Now that I've done step 1 of my problem-solving steps, which is to make one side equal 0, now I need to factor this expression that I've got here, right? I have to factor this as much as I can, and I can see that 4, 16, and 20 are all multiples of 4. So I'll divide all of them by 4, and this is what I get. 4x squared divided by 4 is x squared. 16 divided by 4 is 4, and 20 divided by 4 is 5. And of course, I can't forget that I need to put that number that I divided out, I need to put it in front, because that's what I have factored. Now, am I done factoring? Absolutely not. I need to take this expression and factor it using the skills that I did learn in the previous lesson. So I'll take negative 5 and I'll look for two factors of negative 5 that add up to positive 4. And that is positive 5 times negative 1 gives us negative 5, and positive 5 plus negative 1 gives us 4. And so these are my two factors, and therefore this expression right here factors into x plus 5 times x minus 1. Now that I have it in factored form, I'm done my second step of solving a quadratic, because this equation is much easier to solve than this equation up here. And it's easier to solve because I have it in factored form. I just need to know what values of x will make either of these factors equal 0. So let's take a look at that right here. So these are the two factors. I want to know what makes them equal 0. Let's see, I'm going to say x plus 5. I want this to equal 0. So I'm going to move the 5 over to the other side. I'm going to subtract 5 on both sides. And I'll do the same thing on this side in a minute. Okay, so first let's work on this equation. So I'll subtract 5 from both sides. That'll cancel it out. And I'll be left with just x on this side and negative 5 on this side. And that's true, right? Negative 5 plus 5 is equal to 0. And 4 times 0 times whatever this is going to equal 0. So this is one of my solutions. What about this? X minus 1. What value of x could I put in here such that when I subtract 1, I'll get 0? What number minus 1 gives me 0? It's super easy to know that, right? You would just say 1 minus 1. That's 0. And of course, if we do our algebra steps, that'll confirm it. If I say x minus 1 gives me 0 and I add 1 to both sides, I'm left with just x on this side, and 0 plus 1 is 1 on this side. So both of these will make this equation equal 0. However, this is a real life question, right? What value of x, what is the width of this border to get me an area of 32 meters squared? Well, the width can't be a negative number. That doesn't make sense. So I have to say that I'm going to ignore this solution. My width will probably be 1 meter wide. Okay, that's the width of the border, the stone border. And I'm going to confirm this with a graph. Okay, so in this graph, I've put this equation here, 4x squared plus 16x plus 12. And then I've also put the number 32, y equals 32. And when does this actually equal 32? When does my parabola have the same y value as this line of 32? I can see here that my solutions are correct. Notice that this is a standard form of a quadratic, and it has made a parabola. And I can see that this parabola equals 32, that's my y value of 32, when x is -5 and when x is +1. So I can confirm that when the width is 1 meter, the area of the garden is 32 square meters. And that is step 3. Step 1 was make one side equal 0. Step 2 was factor the other side. Step 3 is figure out what values of x make the entire equation equal 0, or what values of x make each factor equal 0. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.